Well, looks like I got my camera together. What do you think? Good morning, good afternoon, good evening, everybody. Welcome back once again to the channel. You know it is JJ with you for this. Sorry about that. If this is your first time here, make sure you subscribe, hit the like button. That way you can tell those people on YouTube that we are a channel. So that way they'll push our video, they'll push the channel videos out there, so that way you all can get the latest updates on them. It seems crazy. So today we're going to have a little talk about this 12 volt high power. I know they got the 2x6, but we're going to talk about this one right here. And I was sitting here doing my research on this and going through the gauges, knowing this is like really stiff, but I know this cable is really good. I know this one will handle everything that needs to be done. So the point is this. Today's video is about how can I say this? DeBauer made a video on one of the 5090s he borrowed from a reviewer, or not a reviewer, a viewer. And it seems that the melting continues. Okay, so what we're going to do is we're going to talk a little bit about this. I'm going to do best I can to explain it to you all. So hopefully we can get everything, downtown. So that way y'all understand where this is coming from and where this is going to. But from what I see right now is that they're still having the issues. So how to fix this? The only way to fix this is going to be by NVIDIA. But what we can do is we can show you some pictures that we took from DeBauer's video. And don't forget to watch that video. I'll post a link down in the description below. But we're going to talk a little bit about this. So let's get set up and get it started. Alright, we're here on the action screen. As you can see, I already did a few slides. Let me go ahead and get that mouse cursor for y'all, because I know y'all are going to be cursing me out if I don't get a big mouse cursor. So let me go ahead and just get that apparatus going for you. There we go. Alright. As we can see right here, we're going to get into where I put the X. This is from DeBauer. This is his way of showing where the heat is. But what I'm showing is this wire right here. That wire, believe it or not, is not supposed to be like that. It's not supposed to be over 80 degrees. If it is, then there's a problem. And the main problem is going to be that the wire's too small. Okay. NVIDIA claims that they're using 16 gauge wire. This right here obviously shows they're not using 16 gauge, they're using 18 gauge. That can't suffice the amount of power that's being pulled through there. Each wire has to be able to hold 10 to 12 amps, minimal. It seems that it's, you got 6 positive wires, each of them should hold 10 to 12 amps, because if you're pulling close to 700 watts, okay, let's get the calculator out. I know how much you guys like the calculator. Let's get the calculator out. So what we're looking at is this. we're looking at 600 watts, right? And we divide that by 12 volts, gives us 50 amps. Now you divide that by 6 wires, which is 6 positive wires, not the negative, the positive. The negative is just on the return. So we divide that by 6, gets us a total of 8.33 amps. Okay, that is the optimal, minimal that you can be getting off of that. Now, that's with 16 gauge. 10 to 12 amps per on 16 gauge. Now, with 18 gauge, you only can pull up to 7 amps. 7.2 amps. So if we took 7.2 away from the 10 to 12 that it's been pulling, because I've been seeing some reports that it's been pulling like close to 641 watts. So we do 641 and we divide that by the 12, gives us 53.41 amps divided by 6 gives us 8.9, and we're pulling it off of minimal 7 amp wire. So if they're using 18 to 22 gauge, well, 22 gauge only going to hold up to 3 amps. 18 gauge is going to hold up to 7 amps. As we can pull out a relative chart, let me go ahead and get a relative chart for y'all and show you. Okay, we pulled you up a relative chart. Now if you can see where it says gauge wire, or wire gauge, AWG, 16 gauge will pull up to 10 amps. 18 gauge will pull up to 7 amps. 20 gauge will pull up to 5 amps. So 22 gauge will pull up to 3 amps. So my assessment is this. Let me take you guys back to the main screen for a moment. Alright, now we got you back on the main screen. As you can see, the wire here, you don't count the outer diameter of the wire, okay? This is one. Right here. Right here. You don't count the outer shielding. It's what they call the OD. The OD, the outer diameter of the wire. Now you got what's inside the plastic, which is the inner diameter of the wire, the ID. Okay? And my feeling is that they're saying that they're using 16 gauge wire OD. 16 gauge OD. So going back to the action screen again, looking at this, I feel that they're using 18 gauge ID. They could be using a 16 gauge OD, but they could be using an 18 gauge ID. So if that's the case, then what's going to happen is that 7 amps that wire's being maxed out at is going to heat this wire up, and it's going to turn out like this. Let me go back. It's going to turn out like this right here. Yes, I got a few more slides for you all. Yes, I got a few more. But right here, you can see these 2 wires. These are your positive connections. He's demonstrating on his own, not the one that got burned up, his own 5090. This is what's happening. So that's the reason why we're bringing it up today, is if you got a 5090, then you're going to have to find a heavier gauge wire to run that GPU. Because from what he said right here, that it's pulling that one wire right here, that one wire alone that's getting hot. It's pulling 21.35 amps. This is an ammeter. This is measuring in amps. 21.35 amps. So, that's way too much on one single wire. One single wire that's probably 18 to 20 gauge. So, we're going to break it down and get to the final thought of this in a minute. If you look at the wires right here, it melted here. The reason why it melted right here was that in between the wire and the pin connector, it got hot. Because in order to secure that pin connector to that wire, it has to wrap around the fastener jack. It has to wrap around the plastic. So, if they didn't solder this with high temp solder, then yeah, you're going to get this hot point. That's what they call a hot point. Just like over here. That's the reason why they got a hot point. And what that hot point does is it starts here, then starts traveling down the wire a little bit each time, and then gets to a certain point. And then the rest of it will start slowly going down and down and down and down and all the way to the other side. So basically what's happening is each strand is overheating. Each strand in that wire is overheating because you're pulling so much amps from that wire, and that wire cannot sustain the amperage. It's like a hot plate on your stove. What happens when you turn it up to high? It turns red. That means it's hot. Exactly the same thing that's happening here is that you're pulling way too much amps from it, and it's heating up. And it's starting here where they say you lose, you got what they call static electricity in between the two connection points. Wherever there's a connection point, it will cause a heating issue, basically resistance. This right here, if they didn't high temp solder it, they got a resistance point. And then now over here on the other side, they got another resistance point. So now you got two resistance points because they didn't solder a solid connection. And that's the reason why the connectors are melting, is because there's no solid connection between the two. You have resistant points, which causing heating issues. And it's heating up the wire, and more resistance is going to heat up that wire even more and more and more and more. And it's going to go all the way to the other side until something catches fire. Till that plastic, right here, plastic jacket melts completely off. Because of this. Because the amount of amps you're pulling from that wire is going to result into this right here. So, I hope that I was a little bit clearer about this with y'all, but I felt that this needed to be said. And yes, I got my camera fixed. For some reason, it just mysteriously started working. Don't forget your drinking snacks, by the way. So, the whole point is this. Point A and point B. You have resistant point, you have resistant point. Two resistant points. Now, with that resistant point, there's going to be friction. And the friction is the source of a heating area. So the more amps you pull from that friction point, the more that it's going to get hotter and hotter and hotter. So yeah, it's going to melt that whole pin. But the problem's not the pin. The problem is the connection point. NVIDIA, you can take it any way you want, but I'll tell you what, I can take a car amplifier and take that same wire and pull 600 watts off of one single leg. That'll be about 60 amps. That's well over the amount. But you'll see that the pins themselves are not the heating issue. The connection point in between the wire and the pin is the heating issue. You guys can look it up, do whatever you will. But I'm just telling you, as far as I know, and what I've known for over years, they tell you the less break points you have in a wire, the less chance you have of heating. That's been common in the engineering world. The less break points you have, the less chance you have of heating. And in between the pin and the wire, that's a break point. So with that there, each one of those little strands, you only got like 16 to 19 strands. Each one of those strands are heating up individually in between that little point A to point B. Now, if you got that excess amount that's not soldered with high temp solder, then those strands are just crimped. They're not a full solid connection. They're crimped. So there's your break point with it being crimped. Because now it's going to start pulling more juice and more juice, and that's just going to get hotter and hotter right at that break point. So you guys think the pins are the problem? The pins are not the problem. The problem is the manufacturing is the problem. That's one. And two, how in the hell can the graphics card pull more than the others? The way DeBauer put it is he found two of them are pulling more amps than the others. One that was pulling a lot more amps than the other. And I've said this before on many videos. If you guys watch the videos, then you would understand better what I'm talking about. Because it's common sense. Common sense. I'm not going to go and rant and rave about it, but I'm going to say I told you so. That's all I'm going to say is I told you so. And I've had this discussion about the break points. The more break points you got in a wire, the more it's going to heat at that break point. It's not where it plugs in at. It's where its break point is. That's what they missed. They think, oh yeah, it's not making a full connection. You can have just a hair of a connection between each other and create a heating point. But you got a hair strand of a wire that's barely pressing onto metal to metal, and it's causing a break point connection. And it's causing that point to heat up more than it does in between the two pins. Because if you got a 1/4 of an inch of a pin, solid pin to male to female, and you got a 1/4 of an inch stuck in there, you're not going to have that heating source. That's not where the problem is. It's heating up before then. It's heating up between the crimp point of the pin connector, and the wire itself. Do your math, do your homework, check it out yourself, and if I'm wrong, I'm wrong, and if I'm right, then I'm right. But that's where I think the problem is. You can investigate it. This is one place that they didn't look, that they didn't think about, but I put it out there to y'all. So, You'll know what to look for. And an easy fix to that is I would take one pin out at a time, check to see if they soldered it or not, and if it's just a loose connection, I would scrape off a little bit of, down to, I would scrape off a little bit of that tin that's on the top of that pin connection, and then hard solder the, I would hard solder the pin to the copper wire and create a solid connection. That might eliminate your problem. And if it does, then you know where the problem is. I mean, sooner or later, I'm going to depin one of these right here. I'm going to depin one of these, and I'm going to see how they got the connection into here. But it seems that they molded the plastic around the connection points. So this is going to be a little bit of a difficult kind of thing to depin. So maybe somebody can send me one that's depinned, so that way I can show you. But I think this wire here is too hard. It's not soft enough, and the gauge is too small. I can tell you from my professional point of view that the gauge of this wire is way too small to carry 20 amps off of one pin. That's just total ridiculousness. 20 amps off of one pin, that's just total ridiculous. That means there's a problem inside the graphics card if they're not evenly pulling the power amongst all 6 pins. So they shouldn't be pulling 20 amps off of one pin. That's just total ridiculousness. That's like 233 watts off of one pin. Okay, now the 8-pin connector is only rated for the low rating of 150 watts, and that's 8 pins. So you're telling me that one single wire that they put in that 12-volt high-power connector is actually better than a whole 8-pin connector? And you got 4 pins that have 4 separate wires on the 8-pin connector? And you can pull up to, I pull every day 208 watts off of one single 8-pin connector. That's off my graphics card, and it hasn't melted. So the problem is that the hot spot of that is in between the wire and the pin, and that's causing the pin to heat up and melt. Because that plastic that they used on there is not Teflon. It's not Teflon plastic, and they're not using Teflon wire neither. That would handle the heat with no problem. It would stop melting, but I don't think they're going to put that much expense into those connectors. They're just going to make them as cheap as they can. And if they melt, then screw the customer, right? But now it's going to be out there, and everybody's going to know where the problem is. They can investigate it, do whatever they want with this information. It's up to them. It's free information I put out there for you, but that's my thought, and hopefully you take it with either the grain of salt or take it like it's gold, one or the other. But anyway, yes, I got my hoodie on today. We did make it to the end of the video, and hopefully y'all enjoyed it, as well as being informative and entertaining, and so on. But anyway, if this is your first time here, make sure you subscribe, hit the like button, and also too, don't forget about that notification bell so you know when I post the next video. Until the next time and the next video, you know what it is, and we'll see you on the next one.